Hi, I am Sanjay Patel. Today we are going to discuss the concept of cone in three dimension. First of all, I will write the definition of cone in the most general form and then I will explain it by some figure. So let us start. Definition of cone. Let capital V be a fixed point in R3, means in the space or in the three dimension. Then a surface generated by revolving a line passing through V and satisfying a given condition is called a cone in R3, is known as a cone in R3. So this is our definition of cone. Just note that this fixed point V is called vertex of the cone, and the line L, or the line which is passing through the fixed point and satisfying the given condition, the variable line or the line L which is variable is called generator of the cone. Remember, this line is not fixed. It is any line passing through the given point and satisfying some condition. Now, by the term given condition means it can be any mathematical condition. Say, let me explain this way. Say if I consider a fixed point in space, say capital V, this is my fixed point, and I consider a condition that the line passing through V must intersect some curve in the space. Suppose that curve is something like this. Okay, this is a curve, say the curve C, and now I consider a line which is passing through this point V and intersecting the given curve. So like this. So this is intersecting. Remember, this curve is not in the plane, it is in the space. We are thinking the curve in the space. Okay. So this line is intersecting at this point, and it is a variable. Now we rotate this line in such a way that for every position of this line, it keeps on intersecting this curve and passing through the fixed point V. So like this, you will get infinitely many lines which is intersecting the curve. Okay. So as a result, some surface will be generated whose base is this curve, this irregular curve, and its fixed point, this is a vertex. This is a vertex of the cone. Okay, so we are going to understand a cone in three dimension like this. So surface generated by revolving a line which is passing through a given fixed point and satisfying certain condition. The condition can be, as I have explained, that the line should intersect the given curve, or the condition can be the line should touch some other surface like sphere or say something else. Okay. Or we can have some condition that the line passing through V must make a fixed angle with some other line. So this kind of condition can also be there. So there are various types of cone generated by our definition means in the general form. These lines are known as generators or generator of the cone. This is the generator. So a cone is made up of infinitely many generators. All these lines are say lying on the cone. Okay, and basically we are going to understand three categories of cone which is generated by this thing. So first let me write down the three types of cone which we are going to understand in our this topic. So we shall consider the following types of cone. Following three types of cone. Okay, the first one is cone generated by a curve. Okay, or rather guiding. This curve in this above figure is also known as the base curve because the base of the cone will be like this. It is also known as guiding curve. So let me write cone generated by not simply a curve but a guiding curve. And the second type is enveloping cone. Enveloping cone with respect to a given surface. And the third type of cone is very important, and it is known as the right circular cone. The right circular cone. The third one is the standard cone, what you have studied in school, that right circular cone, which has the base as a circle and it has fixed say radius and say slant height and the vertical height and so on. Okay, but remember a cone is an infinite surface. So we are taking only some part of the surface and finding the say volume and enclosed by that surface or say the surface area of that right circular cone. Okay, so let us start with the first one. And remember, after completing the topic of cone, we are also going to learn the concept of cylinder in R3, and it is also defined in a similar fashion. And we also have same type of same three types of cylinders, like cylinder generated by a guiding curve, enveloping cylinder, and the right circular cylinder. So we are going to study three types of cylinder as whatever we are discussing here. Okay, so the first one, the first part is cone generated by a guiding curve, or it is also called base curve. It is also called base curve. Okay. And remember, in this first type, we'll understand how to obtain the equation of cone generated by a guiding curve. Okay, so the figure is same as this. This is actually within this figure, it is a cone generated by this curve. It is also called base curve or the guiding curve. Okay, so let me explain the first type or first category of cone by say some examples. So the first example we are going to discuss is this. Say, find the equation of a cone whose vertex, now we know what is vertex, whose vertex is the point V101 and the guiding curve is given by this x square plus y square plus x square plus y square is equal to say 3 and z is equal to 0. Okay, remember both of these equations here are say in 3 variables. You know, z equal to 0 represents the equation of plane, the xy plane. Z equal to 0 is the xy plane. So here x and y are not written, means they are arbitrary. So in a equation in 3 dimension, whenever a variable is missing, means it is not 0, it is arbitrary variable. You can take any value of that variable you want. So here in this equation, x square plus y square is equal to 3 is not an equation of a circle. Please note that it is an equation of a surface, okay, where z is arbitrary. So we have to collect all the points which is satisfying this condition, x square plus y square is equal to 3, and z you can take any value you want. Okay, it is actually the equation of cylinder that we will see later on. At present, you don't know what is the equation of cylinder, so I am not discussing this. But remember, this is not an equation of a circle. Okay, so let us obtain this equation. Understand this procedure, how to find equation of a cone when the guiding curve and a vertex is given. Okay, remember the cone is a surface. It is made up of infinitely many lines, and these lines are lying on the cone, which are called generator. If you take any point on these lines, as I have shown in this figure, any point on this line, it is on the cone, and conversely, if you take any point on the cone, it will lie on some line. So and these lines are generator or generating lines of the cone. Okay. And in mathematics, whenever you want to derive any equation, then we always take an arbitrary point on that object. So here the vertex is V101 and the intersection of this cylinder and this plane, okay, is given. So let us assume that it is some curve like this, okay, and we want to find the equation of cone which is generated by revolving a line passing through V and intersecting this curve. So this curve is actually the curve given by the equation x square plus y square is equal to 3 comma z equal to 0. This is the equation of the curve C. Okay, so this. So there are infinitely many generators like this. This is a generator. Let me call is say variable line L. Okay, this is generator line. And now I am taking any point on this generator. First of all, remember this line is variable. It is not fixed line. But only thing is it is passing through this fixed point V, which is vertex of the cone. So let capital P, since it is variable, I will take the coordinates as x comma y comma z. Let capital P be any point on this cone. Okay, and since it is on the cone, it is passing through the vertex, and also it is lying on some generator. So I will be starting with the equation of say generator, say Vp. So let me write systematically all these steps. Okay. So let Px comma y comma z be any point on the required cone. Required cone means the cone whose equation we want to find. Okay. Now, capital V 101 is the vertex of the cone that is given to us, vertex of the cone. P is on the cone, V is a vertex. So if you join this V and the point P, you will get this generator Vp. Okay, so this implies the straight line Vp is a generator of the cone. This is a generator of the cone. Okay. Now, since generator, the point P can be anything, and according to that, say position of the point P you can take on the cone here also. Say you will get some other generator passing through this point, and the P point can be here also. So the direction of this generator line is changing. It is not fixed. So it is a variable vector. So I am taking the generator direction as say L comma M comma N, where L M N are say variables. So let L comma M comma N be the direction of the generator Vp, of the generator Vp. So this, whether this generator or you can take this generator, the direction is given by L comma M comma N, and the values of L M N keeps on changing. Okay. Now we know the direction of generator Vp, and also we know it is passing through the vertex V. So I can write down immediately the equation of the say generator line. So therefore, the equation of the generator Vp is given by the equation say x minus 1 upon say L. It is passing through 101 and having direction L M N. So I can write y x minus 1 upon N upon L is equal to y minus 0, the second point is 0 here, upon M is equal to z minus 1 upon N, and is equal to say k, where k belongs to R. And let me call this as say equation number 1. This is my equation number 1. Okay. Now this generator line is intersecting the given base curve or the guiding curve. This is our base curve or guiding curve. And the generator Vp intersects this base curve at some point. So I want to find the coordinates of this point, say P dash or Q dash, whatever, say Q. Okay. So I can write this way. Since the generator Vp intersects the guiding curve or a base curve, say C, given by x square plus y square is equal to 3, comma z is equal to 0, we can find some k belongs to R. We can find some k belongs to R here. so that means there is some fixed number k such that the point on this line satisfies this equation. So what is the point on this line? It is given by x is equal to lk plus 1, y is equal to mk plus 0, and z is equal to nk plus 1. You know how to find coordinates of any point on this equation of line. So since the generator Vp intersects the guiding curve C, there is some k belongs to R such that the point say lk plus 1 comma mk plus 0, that is mk, and nk plus 1 of the line, this point satisfies the equation of the curve C for some particular value of that constant. So we can find some fixed k so that we'll get this three coordinates x, y, z also satisfies the equation of the curve. So we'll put the values of this x, y, z, which are the coordinates of the point on the line which is meeting the curve at the point Q, as I have explained earlier. So I can substitute here. So we'll get lk plus 1 whole square plus mk square is equal to 3 by putting x and y these values, and z equal to 0 gives you nk plus 1 equal to 0. Okay, so we get this thing, and from this equation what we do is we eliminate this fixed constant k. So remember this procedure, eliminate k from these equations, from the above equations. We get, see how to eliminate this. I can put from this equation, I can find k is equal to minus 1 upon n, and then I can substitute this in this equation. So what I will get is this thing, L into minus 1 upon n plus 1 whole square plus m into k is equal to minus 1 upon n whole square equal to 3. So k is removed by say finding or eliminating k between these two equations. Okay. Now let us simplify this. You can see what will be the simplification very easily. This is say minus L upon n plus 1 whole square plus say it is m square upon n square is equal to 3. Multiplying this equation by n square, because you know n square is the say denominator for both of these terms. So I will get minus L plus n whole square, or you can simplify this first, minus L plus n upon n, and then simplifying further we'll get minus L plus n whole square upon n square, and then multiplying by n square. So in whatever way you can find simple, you can do that. So we will get 3n square multiplying both the sides. So this is our equation number 2. This L, M and N, you know, they are the directions of the variable line or the generator line of the cone. So and from the equation 1, you know, this x, y, z which we have taken in the beginning are the coordinates of any point on this line, any point on this cone. So if I want an equation of a cone which is in terms of these variables x, y, z, what should I do is I must eliminate say LMN between the equation of line, that is the generator line, equation number 1, and I must eliminate between equation 1 and 2. So what we do here is we eliminate, so it is the next step, you must remember, we eliminate L, M, N between equation 1 and equation 2 okay. So what you can do is let me write that equation 1 here. What is equation 1? It is this. I can find the value of Lmn by comparing with this k. So I can get L is equal to x minus 1 upon k, m is equal to y minus 0 upon m. Let me write down that equation and explain again. So just I am showing you here as a rough work. So it is x minus 1 upon L is equal to k gives you L is equal to x minus 1 upon k. And similarly, for the second and third term, you will get y minus 0 upon m is equal to k implies k is equal to say sorry, it is not k, it is m is equal to y upon k. We get m is equal to y upon k, and n is equal to z. What was that? Let me check. Z minus 1 upon n. So we will get n is equal to z minus 1 upon k. N is equal to z minus 1 upon k. So we can substitute this the value of L, m and n in equation 2 so that L and n will be eliminated. Okay. So we get this way. Minus L is what? X minus 1 upon k plus n is z minus 1 upon k whole square. M is y upon k whole square, and n is again z minus 1 upon k whole square. Okay, so you can eliminate like this the values of L and n. But remember, we can omit this step. In practice. No need to write this step. Okay, we can directly write without using the k, because ultimately the k will be say cancelled, because we have made the equation 2 a homogeneous equation. So all degrees of k will be same, and every term will be cancelled on both the sides which involves k. I mean the term k or k square will be cancelled. You can see here if you further simplify this. So what we'll do right directly is we'll write simply from this equation that we'll write L is equal to x minus 1. So instead of x minus 1 upon k, I will just substitute L is equal to x minus 1. So what I will get is minus x minus 1 plus z minus 1 whole square plus y square is equal to 3 times z minus 1 whole square. So this is the required equation of the cone. Okay, you can simplify this further. Let me write something more. This is minus x plus 1 and this is z minus 1. So we'll get z minus x whole square plus y square is equal to 3 into z minus 1 square. Okay, which is the equation of the cone. Okay, but in practice you must simplify this as much as possible. So let me simplify. It is very easy. This is perfect square. So z square minus 2zx plus x square plus y square. This is again perfect square. So 3 into z square minus 6z plus 3. Further, this gives us x square plus y square, writing these two terms first. Then z square minus 3z square is minus 2z square. Then minus 2zx minus 6z and plus 6z taking on this side, and minus 3 equal to 0. So this is the required equation of the cone in the question. Okay, so this way you can solve all the problems. Remember, a cone is a surface in 3 dimensions, and every point on the cone lies on some generator, and every point on the generator lies on the cone. Okay. Let us take one more example to understand this. So I am taking second example. It's a similar one. Say find the equation of a cone whose vertex is at the point say 0 0 0, that is origin, and the base curve is given by the curve C. Let me call this vertex V. C x square plus 2y square minus z square is equal to say 2 comma x plus y plus z is equal to 3. So again, this curve is the intersection of this object and this, which is known to us. The second object is a plane equation, but the first object is not the equation of sphere. It is actually known as say a conicoid. It's an equation of a conicoid. What is a conicoid? We will discuss later on, not now. So let us find the equation exactly in the same way. Let capital P x comma y comma z be any point on the required cone. Okay. Since V 0 0 0, since the point V 0 0 0 is the vertex of the cone, it is the vertex of the cone, since V 0 0 is a vertex of the cone, the line VP, the line joining V and P, is a generator of the cone. Okay. So you must write this way. And then the next step is, we suppose the direction of this generator. Let L, M and N be the direction of the generator VP. And remember, this LMN is not fixed, it is arbitrary. So LMN is the direction, variable direction of the generator, say VP, because line VP is not constant, it is not fixed. Therefore, the equation of the line, this line VP is x minus 0. It is passing through 0 0 0 and having direction LMN. So x minus 0 upon L is equal to y minus 0 upon M is equal to z minus 0 upon N is equal to k. So it is nothing but x upon L is equal to y upon M is equal to z upon N is equal to k, and let us always call this as equation number 1. Next step, as the generator intersects the curve C, which is given by x square plus 2y square minus z square is equal to 2 comma x plus y plus z is equal to 3. Okay, there exists some k belongs to R such that the point on this generator, which is given by say Lk, Mk and Nk. As you know, from this equation 1, we can find any point on the line. So x is equal to L into K, y is equal to M into K, and z is equal to N into K, like that. So there exists some K belongs to R such that the point given by Lk, Mk, Nk satisfies the equation of the curve C. Okay, it satisfies the equation of the curve C. So therefore, we have, putting this x, y and z in this equation, we'll get Lk square plus 2 times y is equal to Mk. So Mk square minus Nk square, comma, Lk plus Mk plus Nk is equal to 3. Okay. So this gives us, just a minute, I forgot to write, is equal to 2 over here. Yes, it is x square plus 2y square minus z square is equal to 2. We must write is equal to 2 here. So this gives us k square into L square plus 2m square minus n square is equal to 2, comma, here I can write k, taking k common, I will get L plus m plus n equals to 3. Now what is the next step? This k is a fixed number, which is a point of intersection of the generator and the curve C. So we eliminate this k between these two. So eliminating k now, we get, now how to eliminate k? From this equation, you can find k is equal to 3 upon L plus m plus n. And this value you can substitute in the first equation. So we get k square, that is 3 upon L plus m plus n whole square into L square plus 2m square minus n square is equal to 2. Okay. Let us simplify this. So we'll get 9 times L square plus 2m square minus n square is equal to 2 into L plus m plus n whole square. Okay. So let us call this as equation number 2. Now our next step, as you know, we eliminate L, M and N, which are the direction, and it is arbitrary between the equation of the generator 1, which is, you know, x upon L is equal to y upon m, it is here. So we eliminate the L, M, N between this equation and the equation number 2, which we obtained just now. So as I told you, you just substitute L, M and N directly as this numerator. So L is replaced by x, M is replaced by y, and N is replaced by z. So always replace this direction element by the numerator and you will get the answer directly. So we'll get, by eliminating L, M and N between equation 1 and 2, we have say 9. What is L? Just replace L by x in this case. 2y square minus z square is equal to 2 times x plus y plus z whole square, because L is equal to x, M is equal to y, and N is equal to z. So this is the required equation of the cone. And if you want, you can simplify this further. I am leaving it to you. Just let me write the conclusion, which is the required equation of the cone. Okay. So this way you can find the equation of a cone generated by a given base curve or a guiding curve. So in the next lecture, we'll be studying the second type of cone. Thank you.